Hello and welcome to the Actuarial Research channel, the channel where we break down actuarial exam questions step by step so you can answer them accurately and on time. In this series of videos, I'll be taking you through Utility Theorem. This is the second chapter in the CM2 module, so we'll just dive right into it. I will do a brief intro into the chapter before we go on to do question in the subsequent videos. So, utility is the level of satisfaction an individual obtains from a particular course of action. The utility function is just the measure of the level utility, and with this, the main aim of any investor is to maximize the utility. The expected utility is written as this, which is the expected utility is a summation of the individual probability multiplied by individual utility of wells. From there, we'll go on to look at the expected utility axioms. So there are four utility axioms. There's one, comparability, two, transitivity, three, independence, and four, certainty equivalent. In the first one, comparability, if A is preferred to B, then utility of A is greater than the utility of B. Transitivity, if A is preferred to B and B is preferred to C, then of course obviously A will be preferred to C. So in terms of utility function, it is written as utility of A is greater than utility of B, and utility of B is greater than utility of C, then of course utility of A will be greater than the utility of C. The third axiom is independence. If an investor is indifferent about between two certain outcomes, outcome A and B, then they are also indifferent between the following two gambles. So the first gamble is A with probability P and C with probability 1 minus P, and then the second gamble is B with probability P and C with probability 1 minus P. In terms of utility functions, that will be written as P utility of A, you add 1 minus P utility of C, that will be indifferent to P utility of B plus 1 minus P utility of C. The investor will find a hard time choosing between which gamble to choose. The fourth axiom is the certainty equivalent, and it states that if A is preferred to B and B is preferred to C, then there is a unique probability P such that the investor is indifferent between B and a gamble giving A with probability P and C with probability 1 minus P. In terms of utility functions, it is written as this, where B is the certainty equivalent of the gamble. Moving forward, we'll look at economic characteristics in terms of utility functions. So the first economic characteristic is non-saturation. This is where people prefer more wealth to less. And in terms of utility function, it is the first derivative of the utility of wealth, and it will always be greater than 0. The second economic characteristic is risk aversion. This is just the investor's attitude towards risk, and here it is divided into three. There is a risk averse investor, a risk seeking investor, and a risk neutral investor. So when you're looking at risk aversion, we look at the second derivative of the utility of wealth. For a risk averse investor, it will be always less than 0. For a risk seeking investor, it will always be greater than 0, and for a risk neutral investor, it will equal 0. From there, we'll go on to look at ways of measuring risk aversion, and here we have two, ARA and RRA. ARA is the absolute risk aversion, and it just goes to answer how much do you as an investor hate taking risky bets, no matter how rich you are. And this is how it is written. The absolute risk aversion is written as this, which is just the negative of the second derivative utility of wealth divided by the first derivative utility of wealth. Then we have the RRA, the relative risk aversion, which goes to answer how much you hate betting a percentage of your money. This is how it's written. It is negative wealth multiplied by second derivative utility of wealth divided by first derivative utility of wealth. So we also have the derivatives of ARA and RRA. So ARA is increasing if its first derivative is greater than 0, constant if it is equal to 0 and decreasing if it is less than 0. This is also the same the same explanation can be given to RRA. And one important thing to also notice is isoelasticity, which is something the examiner usually asks. Isoelasticity is just constant elasticity, and this happens when the RRA is constant. From there, we'll go to looking at maximizing utility through insurance. So there are two perspectives to look at this from. So the first one is finding the maximum premium. This is the maximum premium an individual, the insured person, will be prepared to pay, and it is given by this formula. And then the second one is the minimum premium the insurance company or the insurer should charge the prospective customer, and it is given by that formula. So just take notice that when the examiner asks for maximum premium, we are looking at it from the individual's perspective, the insured person's perspective. And when the examiner asks about the minimum premium, we are looking at it from the insurer's perspective. Here I have broken down all the exam questions that the examiner has asked all the way from 2019 to 2025. In 12 sittings, the examiner has asked this question 12 times. So this shows that this is a commonly asked questions. And in some sittings, like in 2024 September, the examiner asked this question twice. So it is only wise that as you revise for your exam, you take this into account. This is the Actuarial Trusted channel. Subscribe and join me as we tackle more actuarial exam questions together. See you in the next video.